All right, welcome back everyone. We're going to dive right into picking up where I left off in the last episode on the resurfacing of the drive rollers for my Makita jointer, combination jointer planer. So I'll pan you down here kind of just to where my work area is going to be and kind of narrate as I go over the steps. I will show you the product real quick. I talked about that. So it's from a company called Smooth On. They make, this is the 770 series. They make several different series for several different things. And as I mentioned, this is a two-part. This is the A part. Let's see here. Yeah, this is the A part. It takes two of those. So there's two containers that came just like this. And then the B part is this one. As I also mentioned, instead of it being done by volume, you can see down here at the bottom, instead of where the ounces would be, it just shows the net weight of 1 pound. So there's 3 1-pound containers. So that's how I'll mix it, even though I know I need about, like I said, that held about 11 ounces of water. So just to be on the safe side, I'll probably do 13 ounces worth of mix. So give or take. So I'll use that graduation as kind of a level where I want it, but I'll still have it on a scale here that you'll see. So I'll still do it by weight so that it's mixed correctly. So let me finish getting things set up here and I'll be right back. Okay, so let's get going here. One more step I did. I bought a product I brought from them is just this universal mold release. It helps to keep the urethane from sticking to the stuff you don't want it to stick to. So I sprayed the inside of the PVC tube and both of the aluminum slugs. So let me tip you down here so you can kind of get a view. Hopefully you'll be able to see most of what I'm doing. I've got a clean graduated container there that I'll mix in. 73 degrees is what they recommend, room temperature for doing the pouring and everything else, and that's 74 degrees in the shop today, so that's pretty much right on the money. Let me get some mixing sticks here. So I'll mix it up, pre-mix it like they mentioned. We've got the scale here. I did, as I mentioned, instead of making a mark on the inside, which would have worked, it would have been kind of hard to see. So what I did is I measured down to the level that it needed to be and just drilled a small hole. So that way when the liquid comes up there, I can see that hole from the inside. And if it would happen to overfill, that it'll just run out of that hole a little bit. So I'm going to get the products mixed here. So as I mentioned, it was 11 ounces, so I'm going to round that up a little bit just to make sure I have enough. So I'll probably go to like 14 or 15, probably 15, because that'll make it divisible by 3, which are 3 parts. So I'll put 5 ounces, relatively 5 ounces. It'll be by weight again, but 5 ounces, so that'll give me an idea where to stop on this graduated container. And each time I'll just add whatever that initial starting weight is to the next measurement. So yeah, there's literally no consistency difference from top to bottom or any kind of solids on the bottom. So these must be either a fairly fresh batch. They do talk about they have a limited shelf life, so you use as quickly as possible. So I suspect that when they create this product and ship it out, it hasn't been on the shelf very long. All right, so let's get the scale on here. So as you can see, I've got the container on the scale so that it takes into account the container and I'm not weighing the container. I have it set on grams, so it'll, maybe I'll switch you around here so you can see. I have it set on grams so it will weigh a little more, a little bit finer detail, I guess. All right, so this, I didn't have any of the smaller paint mixing containers, so I'm going to just kind of have to eyeball the first mark is 8 ounces. I want to go 5, so I'm going to try to go approximately halfway up on that. And then actually for this one I would do about 10 ounces, and then the other one would be 5. So I'll put about what I think is about 10 ounces in it. Look at the weight, and then add that much more. There's about what looks like 10 ounces, so that's 362 grams. You might be able to zoom in. There's 362. So now, since this is the 2 parts, half of that would be 181. So add 181 to that. Make sure I do the math here right. 362 plus 181. I could also zero it. So I'm looking for 543 grams. So now I don't even need to watch the graduation. I can just look at the scale. There we go. A couple grams over, which is a minuscule amount. Get the lids on. It's got a kind of an odd smell. So I can get rid of the scale here. Take a clean mixing stick. This is going to be, I think I can tell, quite a bit more than I'll need, but I'd rather have a little extra than to run out. All right, that's probably been 3 minutes, give or take. Actually, it might be kind of, I'm gonna almost have to kind of pour it straight down, because with the shaft in the way, it would be a little tricky to try to pour from the side. Make sure you guys can see this, and here we go. I've got the hole facing me here, so okay, that's right to the level of the hole. I might just do a tick more. I can always clean that off later if need be. I got a little on the shaft anyway. Spilt some on the bench. That's not the end of the world. Get this other spacer in there. And that's it. Some of it ran down the side here that you can't see. Try to scrape that off. I'm gonna go get a board to put it on so I can clean up my workbench. I have no idea how hard it'll be to clean that off. step I forgot, and I'll just cross my fingers. I had planned on the outside on that other plug, putting just a little bit of hot glue just to make sure there was no chance of it leaking, and I forgot that. So hopefully with the viscosity of it and as tight a fit as I had there, that won't be a problem. Okay. That's that. Not too hard to clean up. And I used brake clean on that first spot, and it seems to cut it just fine, so it's soluble by one down. Let's cross our fingers, wish me luck, and hope that it comes out. So I'll give it a good 16 hours, and I'll bring it back, pull the plugs out, and the way I'm going to demold it is I'll set up the blade on the table saw to be, you know, maybe a 64th of an inch or so shy of the full thickness of that PVC, and then I'll just run it through the table saw lengthwise to put a slit down each side of the PVC almost all the way through. That way I don't nick the aluminum plugs. And then probably just take a razor blade or an X-Acto knife and split that last little tiny bit. That'll let me take the two halves off if all went well, and then hopefully the two slugs will just pop off the end of it. So I will bring you back and show you what they look like. Thanks for watching. All right, everyone, welcome back. It's kind of the moment of the truth on the planer joiner rollers. To be honest, I thought about, when I shot the first episode, I thought about not even posting it until I was done to make sure it worked out. But then I thought, nope, you got to take the good with the bad, and if for some reason this pour didn't work out, or I mixed it wrong or something and it doesn't turn out, might as well share that with you guys also, and that way if you decide to try something like this, you might learn some tips or tricks, or I might myself learn some tips or tricks, since this is the first time that I've done it. So as I mentioned, so here's the piece before I done much. The plug did not leak any, so it should still be just as full as what it was. It's quite heavy, actually. So as I mentioned, I've got the table saw set up. I'll swing you around here in a minute. So I'm just going to do two longitudinal cuts down the tube opposite each other, almost all the way through to the aluminum. And then I'll use a razor knife. I'll probably sneak up on it too into a couple different cuts, and then see if the outside shell breaks away okay. And then we'll see what it's like. So let me swing you around here and we'll get going. I don't know what it'll be like with the volume of the saw. There might be, whether I narrate much, you may not be able to hear it, so we'll just see how it turns out. I do have this fence set to half the diameter of the pipe, so that way I pretty much guarantee that it's going to be in half. Go find my glasses. And if anybody was worried that I set if I got the blade too deep, even if I touch the aluminum, it's a typical carbide blade, so it won't hurt the blade any. So there's the first pass. You can see I'm really close to touching the aluminum. I might just tweak it up just a little bit and try to get right there. plastic open up so that was just the right depth. I barely just kissed the aluminum. So that's the right amount. Let me get you back up here so you have more of a bird's eye view. All right, so you should be able to see that there. It's easily wanting to pop right off. So that means the release agent worked well. This end's a little glued on. I'm just looking to see if there's any, it even came out that little hole like I mentioned and left that little nub in there. I can see like a few miniature tiny bubbles, but overall the outside finish is quite smooth. So, and it's, I would guess about the right durometer. I can push it in with my finger, and you probably can't see there, but I can push it in with my fingernail, but it's very, very firm. So I think that is a success. So I'll get this other piece, this other end cap off. Let me find something to pry on it here with and see if it pops right off, because that was the cap that was the end that was tapped in. Was actually a snug fit. Once I drove it in, it actually gripped it. So we'll see here if it'll break loose easy enough. It doesn't appear to be stuck because of the rubber. It's stuck, I think, because of, again, it's a kind of almost a press fit on it. So let me, I'm just going to go over to the vise, clamp this in the, I'll just bring you over here, clamp it in the vise and give it a tap on the end and see what happens. Get the really big hammer here. Yep, that's all it took, just to break that little bit of a press fit on that slug. So I give you a look there at the end. Nice and smooth there. Both ends actually. This is the end that was poured, and so it has a little bit of a cup shape to it that'll clean up just fine. So I think again that's a success. I'll take it over to the lathe here and show you that. I'll spin it just to see how much if it stayed centered pretty well. I already know that, as I mentioned, that I'll have to take some material off. So even if it has some run out, it won't matter because I can clean that up when I make it the appropriate OD. So let me tuck back here at the back of the lathe. Get some light. Alrighty. Come around from my view, you can kind of see that if you line that up against something in the background, I bet you there is no more than 7 or 8 thousandths run out on that. Just for kicks, let's put a dial indicator on that and see what it says. We'll go to the middle. There's a total of about 13 thousandths run out. Part of it is that the saw blade did just touch it. Let me see how it happens to be along the length. So we're about 0 there, maybe +1, and we're +4 there. So I actually am tickled pink with how that came out. I'm not going to cut it tonight because I've got some other things going. But at least I know that I can go ahead and pour the second one with the exact same technique, and it should come out good. So anyway, maybe you guys, if you've got something, doesn't even have to be a set of drive rolls for a planer. If you have something that needs some kind of a rubber grippy surface on it, that gives you an idea of what you can do and can't do. Overall product that I had left, as I mentioned, I didn't want to run out, so there's probably maybe half, not even that, 1/4 to 3/8 of an inch in the bottom of that mixing bucket. Same thing, it's set up that same. So anyway, thanks for tuning back in. I will, probably no point in showing you the second pour. That'd be kind of silly because it's the exact same thing unless something goes wrong, and then I'll show you that. So I'll get the second one poured. I'll experiment a little bit with what technique's going to work on the lathe, where they're just a very, very sharp high-speed steel tool will work, or whether I need to, like I mentioned, set up a way to try to grind it. So anyway, stick around. That probably won't be a separate episode. It'll probably be in this episode because I'm only into this, looks like about. Okay, so we're back over here at the lathe. I got the other mandrel B-mold or drive roll demolded. Let me grab it here. And it also came out just fine. So I've got the one in the lathe and then this one that I just demolded this morning. So I've been kind of experimenting a little bit with how to turn them down. And I tried carbide as I expected. It really isn't sharp enough. It kind of works. So then I had a traditionally ground high-speed steel tool bit. It worked okay, but I think given I have 100 and some odd thousandths to take, I would have been here a long time. So, because as soon as you imagine, if you try to feed in too much, since it's rubber, it, for the most part, the tool kind of just deflects into the rubber and it does cut it a little bit, but not that much. So then I reground a tool bit. Let me show you here. And it's not perfect, but it seems to be somewhat working. So it has about a 45-degree angle on it, honed the edge. So try to hold it here to where you can see how it's working. I'll give you a close-up. But as the drum's rotating, it comes down. Instead of using the point like you kind of normally would, I've got it set, the tool bit height set to where it comes in the middle, so you kind of get a shearing, almost like if you had held a knife flat, kind of like filleting a fish or something. So that seems to be working pretty well. I'll tip you down here. So anyway, I set the feed rate really, really fast, so I could just make several passes pretty quickly, and then I'll come back with a finished pass. Though this was a fairly high-speed one there, and it did a pretty decent job. So anyway, I'll just start cutting away, and when we get close, then hopefully there's some of these bubbles that were what's the word I want, encapsulated in the rubber, that some of those might get exposed, but it shouldn't hurt anything. So let's make a couple passes here and see what happens. I'm doing 20 thousandths at a time. It's probably not cutting actually that much. I'll move you over to this side so you can see kind of what the chips are like coming off. So I'm setting it at feeding 20 thousandths, but it's because there's some springiness to the rubber. I seriously doubt that it's not cutting that much. So let's see, I gotta move you back a little because the carriage will hit the tripod. And that should be clear and you can see. So you can see it looks like it's leaving a really rough finish, but it's just that the rubbery stuff, when it shears it off, it just kind of sticks to it. And like I said, that's a really fast feed. So let me grab my calipers. 1" 90 900 before I took that first two cuts. We'll see where we're at. Yeah, it's definitely taking material off. We're at 1" 700, or excuse me, 1" 800, and we were at 1" 890 to start out. Now we're at 1" 875, so we took about 15 off. So I'll just keep picking away at this, and you'll either see all of it in fast forward, or if it's too long, I'll just bring it back when I'm closer. Yeah, that leaves a pretty nice finish. There's a few little spots where there was, like I said, some of those bubbles that were uncovered. And going slow like that cut quite a bit more material by a long shot, which kind of reinforces the fact that there was indeed some spring back. Because I'm actually at, good thing I didn't do much more. I'm at 1. I was shooting for 1 3/4, so 1" 750 thousandths. I'm at 1" about 770, 775. And that was 770 was on when I measured the original rollers that had kind of degraded. 770 was the biggest measurement. However, there's really no way of knowing for sure when it degraded like that, whether it shrunk, whether it grew bigger. So I did put these in the milling head of the planer and measure across both rollers down to the knives to see how much in that 1 3/4 was about right. But I think I'm going to stop there because the rollers do sit in pillow blocks. Actually, I can take you over there and show you. They do sit in pillow blocks that are on springs. So the drive rolls fit in these pillow blocks here, which sets the height, one on each side. But as you can see, there's springs in those pockets. So you actually have those. Those will contact the wood quite a bit before the knives would ever touch it, and then those springs allow it to squeeze down, and that's what kind of gives it grip on the wood. So even if I'm not exact on the diameter of the drive rolls, those springs will account for some of the height variations. And also, Makita was pretty smart when they did it. They bored these holes off center in these pillow blocks. So as the drive rolls wear, you can flip them 180 degrees or even 90, because there's 3 completely separate depths. So don't know whether they did that intentionally, probably. to account for drive roll wear or knife wear, things like that. So at any rate, I think I'm going to stop right here. I might throw some emery cloth on it to see what that finish does. But as I mentioned, having it a little bit coarse or a little bit fuzzy, if anything, should actually help. Help with the grip, I would think. So, but I would like to take just these little air pockets have a little bit of a bump on them, so I'd like to get those out. So I'm going to try that with some finer emery paper, and we'll see what happens. Yep, that did a pretty good job of knocking them off. There's a little bit of a, almost like traction. Let me bring you in really close. I don't know what the camera will do as far as focus wise. I'll flip you to the other side. You can kind of see that texture there. So I'm hoping it's, compared to my thumb, you can see how close I am. So the texture's not massive, but I'm hoping that that actually allows for a little bit better grip. So I'm gonna, the other one again is a rinse and repeat. You don't need to see me do the other one, so I'll bring it back here in a few. Okay, so that second roll machine just as well as the first one, it actually had a little bit smoother finish because the since I knew what dimension or where I needed to be on the feed wheels on the lathe, I went to 1/1000ths under what I did on the other one, and then made one final 1/1000ths cut, so it ultimately made a little bit finer finish, which really doesn't matter, I guess, one way or the other. So that's pretty much it for this. The rest of the assembly isn't really a build it or buy it type thing, so I'll probably wrap it up here. This will just be a 2-episode series. I won't leave you hanging when I do have the planer all cleaned up and back together. That was frankly the only parts that needed any attention. So when I have it all cleaned up and put it back together, I'll probably just give you a short video showing you it in operation. But other than that, I'll get this stuff cleaned up and probably get started. As I mentioned, I have the steel for the next series, which is the 20-ton hydraulic press. So I'm going to get that steel brought in the shop here on the work trailer and get started on that. So again, thanks for watching, and like and subscribe. That helps me out. I will swing you around here as a parting note so you can see the drive rolls, how they sit in the milling head. So as you can see them there, they just set in those pillow blocks. That's the second roll that came out a little bit smoother. So, and then there's the rotating mandrel that holds the knives. So anyway, thanks everyone. See you next time.